Okay, so let's look at some basic trig identities that we're going to use throughout this chapter. The first set of trig identities come from having a right angled triangle that has a hypotenuse of length 1. Okay, so let me draw a right angled triangle. Here's our right angle. And let's say this side is 1 centimeter long. Oh, sorry, well, it doesn't actually matter what unit it is. Well, let's say it's just 1 long. 1 centimeter, 1 meter. That's the length of that. And then we have some angle here, theta. We're going to label theta, and it doesn't matter what the angle is. It could be anything. But let's look at some of the properties that come out of this right angled triangle where we have a length of 1 as the hypotenuse. Okay, so using SOHCAHTOA, what we're going to do is try and find out the lengths of the other two sides here in terms of this angle and this length here. So first of all, there's a right angle, this is opposite, so this would be the hypotenuse. Okay, and if that's our angle of interest, this would be the opposite to that angle, and this would be the adjacent. Now, I want to work out this length here, okay, the adjacent, so A, and I have the hypotenuse, so I'm going to use the cosine. Okay, so cosine of the angle theta equals, well, adjacent over hypotenuse. Okay, but that would just be the adjacent, okay, divided by 1. Well, anything divided by 1 is just itself, so what we have here is that cosine theta equals the adjacent. So this length would be cosine of the angle. Okay, so if that's a hypotenuse of 1, this would just be cosine of the particular angle we have here. Okay, and let's work out the opposite as well. So the opposite and the hypotenuse, we would use sine theta equals opposite over hypotenuse. Well, the hypotenuse is 1, so we have opposite divided by 1, which is just again the opposite. So we have that sine theta equals the opposite. So this is sine theta here. Right, so we have our right angle triangle where this length is cosine of that angle and this length is sine of that angle. And that only works if, well, that's true when the hypotenuse is 1. Right. But what would tan theta be now? Well, we've used sine and cos. What would tan theta be? So this is the actual first identity that you should make a note of. Tan of an angle. Well, tan theta, if we go back to SOHCAHTOA, is the opposite divided by the adjacent. Well, the opposite is sine theta. So sine theta is the opposite divided by the adjacent. Well, the adjacent is cosine theta according to this triangle. So we have that tan theta equals sine theta over cos theta. And well, let's just see if that works. Well, okay, let's pick an angle. Let's pick any angle for theta. We could right, let's pick something like 73 degrees. Alright, and on our calculator what we'll do is we'll work out tan of 73 degrees and see what that comes to. So let's work that out. Let me just check that I'm in degrees. Okay, yep, I'm in degrees. So I want to do tan of 73. And what number do we have? 3.271. Let's say 3.271. Okay, now let's see if this rule works. So now what we'll do is we'll work out this side as well and see if we get back to the same number. Sine 73 divided by cosine of 73, and let's see what number we get. We should get the same 1. Right, so let's do a fractions template first of all, because we're going to do division and it's easier to do it that way. So trig sine 73, and then the bottom one we will do cosine 73 and press enter, and look, we get the same exact number. Okay, so it works. So we have this rule here that tan of an angle is the same as just doing sine of the same angle divided by cosine of the same angle. And right, remember this because we're going to use that a hell of a lot in the clips to come. So remember this rule, that tan of an angle is the same as doing sine of an angle divided by cosine of the same angle, and it will work for pretty well any angle really. You can, not just 73. I'll just pick that out at random. You know, you can try it for yourself for some of the angles. Right, the second identity to come out of this same triangle. Right, well, it's a right angle triangle, and you should know certain rules. Well, SOHCAHTOA works for right angle triangles, but there's other rules that, well, the other rule that works for right angle triangles is Pythagoras. So yes, let's use Pythagoras' theorem and see what the second identity is. So let me actually make a sketch of that right angle triangle again. So we have a right angle here, like so. Okay, and this is side 1, and we said that's theta, this is cos theta, and this is sine theta. Okay, what does Pythagoras' theorem say? It says that if you take the shorter sides and square them and add it together, you get the hypotenuse squared. So a squared plus b squared equals c squared, right? So, well, what does that mean here? Well, if we take this side, which is cos theta, and square it, cos theta squared, okay, and add, well, this side squared, so sine theta squared, we should get the hypotenuse squared, which is 1 squared. Well, 1 squared is just 1, isn't it? So, so what rule do we have? We have cos squared theta plus sine squared theta equals 1. Well, this is the way you would type it in on the calculator with the bracket and the squared, but algebraically, this is how we actually should write cos theta all squared. Like this is the correct way to write this. Okay, and this is just a new notation of how to write cos theta squared. Cos, you put the square sign here and then theta like that. Okay, and then the same thing here, sine. Okay, that tells someone to take cos theta and square. This here is identical to this. And, well, let's just check this works. Okay, let's just check that. If we take an angle and we do cosine of it and square it and add sine squared, sine of that angle squared, do we get 1? So this is the, this is the identity you should remember, really, this here. Okay, so let's just check it works. Let's pick another angle. All right, theta, alright, let's pick something like 104, right? 104 degrees. Right, now let's just do, this is how I type it in on a calculator. Cos 104 squared plus sine of 104 squared. Okay, and let's see what that comes back to. Let's check that out. Okay, so bracket, I want cos 104, okay, push across, and I want to square that. And I want to add it to bracket, trig, and I want sine 104, oops, not 14, 104, push across, square it, okay, and press enter. What do we get? We get exactly 1, as predicted. So it does work, okay, and you could check it for yourself. You could check it for some other angle if you wanted, any angle you want. You know, go nuts. You could do maybe 343 degrees, or maybe 1041 degrees, you know, check it, it should work. If it doesn't, the calculator's broke, obviously. Right, but that's the identity to remember. So, so if you want to take away 2 things from this here, first one is tan of an angle is the same as doing sine of the same angle divided by cos of the same angle. That's rule number 1. Okay, and that'll work for any angle. Okay, second one, cos squared of an angle plus sine squared of an angle will always equal 1. Okay, will always come back to 1, no matter what the angle is, as long as it's the same angle. Okay, so there's the second rule to take away from this. Right, just a side note. Okay, just a side note. Don't get this confused. Right, cos squared theta is the same as doing this, really. Cos theta all squared. Okay, that is equivalent to that, right? That's what we type on the calculator, and this is kind of our notation, right? But don't get it confused with this, cos theta squared, right? Because what's happening here in this particular one here, cos theta squared, is you're actually squaring theta first, and then you're taking the cosine of that, right? So don't get this confused with these two, okay? So just make a note of that. Don't get this confused with this. Right, but those 2 rules are essential, so make sure you know them. Okay, know this. Very important. Right, okay. And that's it for now. There's more to come.